So we need to discuss a little bit about the powers of I. We skipped over this part of the lesson. But what we're looking at here is like the cycle of I, and it doesn't continue on forever because we're going to see there's a pattern. So on worksheet 3A at the top, it says I to the first power, we just call that I. But if we square I, remember we squared both sides, knowing that I was the square root of negative 1, if you square both sides of that equation, you end up with I squared coming out to negative 1. Now when they have I to the third power, mathematically you could break that down to I squared times I. And since we just found out that I squared is really negative 1, that's really negative 1 times I, and that's why they're coming out with negative I. And then they keep going with I to the fourth power. You would break that down into an I squared times another I squared. There's other ways to break it down, but that's the easiest way. We know I squared is negative 1. We know another I squared would be negative 1 as well. So negative 1 times negative 1 is how they come up with positive 1. Now, they kind of continued on with the cycle here, and they kept breaking down like I to the fifth, I to the sixth, I to the seventh. And look what happens with the pattern. It starts repeating. I, negative 1, negative I, 1. I, negative 1, negative I, 1. It's going to keep going that way. So what happens is if you can figure out where in the cycle you're at, you know what it is. Remember our test on Thursday, you're not going to be able to use this fancy calculator. You've got to use one of these old scientific ones. So there's no complex mode on those calculators. So you're going to have to figure out something like I to the 271st power. So a not effective way to do that question would be to write out I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the... That would take you a really long time, right? So let's recognize the pattern instead. So there's two methods for how to figure it out. For our class this year, I'm just going to show you one method, and then if you personally do not like this method, I'll show you the other one. But last year the kids told me they didn't like the second method and just to never show them ever again. All right, so if I think about this cycle repeating every 4. So like, for instance, here, I to the fifth power. If I divide the power, 5, by 4, he doesn't divide it in evenly, right? It's 5 divided by 4 is 1 with a remainder of 1. Like, go ahead, type on your calculator, 5 divided by 4. You get 1.25. So this is the whole number part of it, but this is the remainder. So if you look at the remainder, that tells you where in the cycle you are. So if you have a remainder of 1, and what does a remainder of 1 look like? It looks like a 0.25 decimal. That means you're on the first level of that cycle, that power cycle. So when I look at I to the sixth power, what's 6 divided by 4? 1.5. So that would be the second level of your power cycle. So if you get a remainder of 2, which looks like 0.5, you're at negative 1. And then the next one would be 0.75. And then what happens is if you're on the fourth level of this power cycle, it's going to divide in evenly because it's like your 4s, 8s, 12s, 16s. So you're going to get no remainder. There's nothing after the decimal point. And that means you're at 1. So all you really need to do is to memorize this order. Once you have that memorized, this answer becomes very easy to come up with. So like, for instance, what if I have I to the 251st power? Well, I'm surely not going to write that out, but what I am going to do is type 251 divided by 4 on my calculator. And I don't really care about the whole number part, but give that to me anyways. What does this come out to? One more, a little louder. 62.75. So this is the, think of it in quarters, this is the third level of the power cycle. So if I think about my order here, that was one down here, negative I. This comes out to negative I. So what about I to the, I don't know, someone make up a really gigantic number. It's a lot of pressure, I know. Wait, what? 7 million? It's too many zeros. We're too lazy for that on a Monday. Okay, give me a 4-digit number. Thanks. Go ahead and divide that by 4. Tell me where on the power cycle of I are we? We're 0.5, so on the second level of the power cycle, which would be I squared, which is negative 1. Very good. So when you give me an answer of I to whatever power, you're only going to give me one of these 4 answers. Either I, negative I, no. I, negative 1, negative I, or 1. So this is all you need to memorize. The other method involves you splitting the powers into like multiplication and using exponent rules. I saw a lot of head shakes. Okay, never mind. All right, so here's the two methods illustrated. Like we said, if you really want to talk about it, you sure can. I like the power cycle of I with the division. I will give you a calculator. Now, just so we're clear, if you ever had to do this on your SAT test where there's no calculator allowed on half of it, that would require you guys to pull out old school long division. You got to be kidding me, Bruzo. No, I mean it. 4th grade math, you got to remember it. Okay. Don't worry, because we're going to discuss long division of polynomials coming up in our curriculum, and you'll be like totally refreshed on it. You'll be fine. All right, so we already discussed all of this. I'm just looking through the notes real quick, trying to figure out if I needed to go over anything. You had a couple in your homework that were like this, right? And all you had to do was match up the real and the complex parts. So, like right here, it said the real part is 2a, and it's supposed to equate to 6. So doing a little math there, apparently a is 3. And then for the complex or the imaginary part, 5i is the same thing as bi. So when they ask me who b is 5. So I think there was 1 or 2 on your homework assignment from the textbook that looked kind of like that. All right, moving along. We're still going to talk about complex numbers, but this time we're going to discuss on worksheet 4 the back side of worksheet 4, so 4b. Or not. There we go. Find this. We're going to rediscuss solving quadratics, but if you remember from our lesson last week, all of our quadratic algebra questions, they all came out to real solutions. We're no longer going to have real solutions only. Sometimes we'll have complex solutions. So worksheet 4b, we'll come back to the graphing one. But for now, we're just going to rediscuss solving. So the method that they want me to utilize here in number 8 and 9, solve each equation by taking square roots. Do you have these questions on 4b? Am I looking at the right thing? Oh, good. Okay. So solving by square rooting, first step would be to subtract 5 from both sides. So 10n squared equals negative 76. Now when you divide both sides by 10, do not go the decimal route here. Bring it back to a fraction. So please math enter that fraction for me. Excuse me. I know it's negative. So one more time. 38 over 5. Fantastic. Okay, so algebraically, I know we're supposed to square root both sides. Man, this is a good problem. This is going to discuss a lot of stuff that you might not remember from algebra. Okay, when you square root a fraction, you still square root the numerator and denominator separately. The other thing you have to remember is when you're square rooting an equation, because of the quadratic shape, you have positive and negative solutions. So first thing I'm going to write down is n equals plus or minus, because after all this work I'm going to forget the plus or minus if I don't write it now. And then I have the square root of negative 38, which is different than the square root of 5 in the denominator. So I'm going to look at each of those radicals individually. The square root of negative 38, it does technically reduce, because negative 38 you could think of as square root of negative 1. Now 38 as a number does not have any perfect squares in it, right? It's not divisible by 4 or 9, 16, no, none of those. So I'm just going to think of it like this, because what's the square root of negative 1 again? That's just I. So then what do you think about me saying my answer is n equals plus n minus I times the square root of 38 over the square root of 5? You think a teacher would accept that in PreCalc? No, because there's some weird rule out there that says I'm not allowed to have a radical in the denominator of my fraction. So now you guys have to do that thing that's called rationalizing the denominator. You have to figure out a way to square the square root. That's how you get rid of a square root. So squaring just means to multiply by yourself. So what if you just multiplied the denominator by another square root of 5? However, you got to keep your fraction balanced. So if you did that to the denominator, remember you also have to do this to the numerator. So the actual solutions are n equals plus and minus. I'm going to keep the I out in front. But square root of 38 times square root of 5. Smush those together for me. 190. Oh, good. Good. Go me. All right, square root of 190 over square root of 5. Square root of 5 is square root of 25, better known as 5. Now, 190 is square rooted right now. It does not simplify with the 5 in the denominator. 190 also doesn't have a perfect square in it. It's not divisible by 4. It's not divisible by 9. I don't think so. 19 and 10 don't have factors that'll break down. So these are your answers. But you see what I'm saying here, guys? A lot of kids think the 190 and the 5 can cross cancel. That's not a 190. It's the square root of 190, which is something atrocious. All right. Sorry, that was a really fun one to start with. Happy Monday, everybody. All right, moving on to number 9. We're going to add 10 to both sides. So 4n squared equals negative 28. Okay, at least this time we don't have a fraction. So n squared is negative 7. So square rooting both sides. Square rooting rules of equations still apply. Your answers are both positive and negative. But the square root of negative 7, while 7 does not break down, you do need to think of it as negative 1 times 7. Because y'all are going to tell me what's the square root of negative 1. It's just an I. I used to have a kid in Algebra 2 years ago who told me, I think of it like we're poking the I out of the number. Like, poke. I'm like, oh, that's precious. Not mathematically sound, but it's cute if you want to remember it that way. Whatever. All right. Lots of Algebra 2 work, right? This feels very reminiscent of Algebra 2 work. I know it's been a few months, but solving each equation by completing the square. So completing the square, our first step is to make sure that your A coefficient is a 1, which it is. If this is not a 1, you'd have to go through and divide by whatever that coefficient is. So the next thing we have to do for completing the square is shuffle the constant that already exists over to the other side, and I would leave a blank so you can complete this quadratic. So if we subtracted 91 over to the right, you also have that same blank over here. So recall, what goes in the blank to complete your square? You take half of your b term, and then you square that number. So 5 squared would be a 25. And the reason you stick to that formula is because now this quadratic factors beautifully into x plus 5 times x plus 5, which we're just going to write as x plus 5 squared. And it's Monday and I can't add negatives, so what's negative 91 plus 25? Negative 66. Okay. All right, we're ready to square root both sides. So same rules apply from algebra. This is now x plus 5 equals, I still have a plus or minus on my solution radical. Okay, let's think about 66 by itself for a moment. 6 and 11 are not perfect squares. I don't think it's not broken down with any perfect squares. So all you need to do is think of it as negative 1 times 66. So we're going to write that as I times the square root of 66. But we're not quite solved because your last step would be to subtract this 5 over. So your solutions, the easiest way to write them would be negative 5 plus and minus I times the square root of 66. The location of the I can either be in front of the radical, it could also be behind the radical. I just need you to be careful that if you wrote the square root of 66 with the I after the radical, make sure it's like way outside, like clearly outside of your radical. Sometimes we get a little sloppy and we write that. And that would not be okay because you're indicating you're taking the square root of I as well. I know Mrs. Gupta's calculus class, she generally puts the I after the radical. So it's okay. I purposely put it in front for that reason right there because sometimes I write sloppy and then the radical extends too far. All right, let's just do another completing the square. So it is a 1 in the coefficient, that's good. We're going to add the blanks. And I'm going to move this 12 out of the way. So we're going to subtract 12. Same formula for filling out the b term. You take half of the middle term here. Excuse me, the c term. Half of the b term and then square it. So negative 8 squared would be a positive 64. We use that exact formula so that way we can factor this into x minus 8 quantity squared. What is that? Was it 52? That's not negative, Abruzzo. Man, they messed with us. Are we going to have an I in this solution? We are not, and that's okay. Because there's going to be a time in your life coming up shortly where they scramble together real and complex solutions in one section. So you have to kind of be flexible about that. So x minus 8 equals still positive and negative. I don't have to worry about breaking down with any i's. However, 52 does break down. Isn't 52 divisible by 4? 4 times 13? Okay. So this is the square root of 4 times square root of 13, better known as 2 square roots of 13. Nice job. So final answer set, I'm going to add the 8 over. 8 plus and minus 2 square roots of 13. Fantastic. Was that the same question that was on your worksheet? Okay. Excellent. Okay, and this is fun, and this will be like it is on your homework. Any method you want. Now, are you going to be able to factor with i's? I mean, there is a way, but I haven't shown it to you, so we're going to go with no. So, unless you see some obvious factoring, I might encourage you to step away from factoring as a method when you get to this section of your homework, because factoring doesn't always work, at least not easily. So what are some methods that always work? Completing the square always works. Sometimes it's not fun, though. And then quadratic formula always works. So, look at number 12 and think about your approach. I see 2a squared plus 2a plus a equals 0. That's an equation. Look at all those coefficients, guys. They're all divisible by 2. So since it's an equation, let's knock it out. Divide everything by a 2. So now it's a squared plus a plus 4 equals 0. I can already tell that's not going to factor, so I'm not going to bother. So now it's your choice. Now, I really like completing the square. I think it's great. But I'm kind of thinking ahead and completing the square. If I was to complete the square in this question, I'm going to have a fraction, aren't I? Because 1 divided by 2 and then squaring it. Fractions are not the end of the world. If you don't mind fraction work, go ahead and complete the square. Me personally, I love completing the square. I don't care about fractions in this case. I'll still use them. But just knowing what I know about you guys, you're probably going to say no thank you to that. And you're going to try quadratic formula. You want to go that direction? Okay. Quadratic formula. Or do you have strong feelings towards completing the square? No? You have no feelings whatsoever because it's Monday and you don't care. All right, quadratic formula is opposite of b. So who would be the opposite of our b coefficient? I heard a negative one. Thank you. Plus and minus. Square root of b squared. I'm just going to write down a 1 instead of writing 1 squared. Minus 4 times a times c. Oops, I got a little crazy with that fraction bar. There we go. All of it over 2 times a. All right, so I would like you to calculate the discriminant first. Do not type the square root because this is going to be a little funky, but 1 minus 16. This is going to have an I, isn't it? All right, so negative 1 plus and minus the square root of negative 15 over 2, all of it over 2. Now, 15 as a number is not going to reduce for square rooting, but the fact that there's a negative means that we're going to poke the I out, if you will, but it is negative 1 times 15 in the radicals. So our solutions are negative 1 plus and minus I times the square root of 15, all of that over 2. There's no further simplification because all of the coefficients are not divisible by anything, and that's our final solution set. Walk away from that one. Now there are 2 solutions there, right? Negative 1 plus I squared root of 15 over 2 and negative 1 minus I squared root of 15 over 2. I will not have you guys separate them. Yes? Sure. So I know I'm going to go from the secondary line where it was just a squared plus a plus 4, was it, when we divided by 2? Okay. So completing the square, we would move the 4 over and add a blank. So now it's a negative 4 plus blank over on the right. So this cut in half and then squared, there's like a 1 here, right? So 1/2 squared would be 1/4. And then factoring, it's always x and then plus half of the b term for the factor. So in our case, it would be a plus the half, quantity squared. All right, so this requires a little common denominator work. Negative 4 plus 1/4 would be like negative 16/4 plus 1/4. And this is where our negative 15 is coming from. And square rooting both sides. So this ends up being a plus, you guys don't have to write all this down if you're not curious. A plus 1/2 equals, same square rooting rules, I'll write plus or minus I'm going to break down these radicals, numerator and denominator, separately. And this is how we're going to get an I times the square root of 15 over 2. And then our last step would be to subtract this 1/2 over. So there's nothing wrong with writing your answer as negative 1/2 plus and minus I times the square root of 15 over 2. However, since they have common denominators, we could smush those fractions together and call it negative 1 plus and minus I squared of 15 all over 2. Oh, I kept saying x equals on that problem. Silly me, that was supposed to be a equals. So we do get the same solution set. It's up to you. So when given a choice, it is literally up to you. Now when I look at the next question, as much as I love completing the square, because look at the next question. The first rule of completing the square is that your first coefficient, your a, has to be, sorry about this a here. Your first coefficient has to be a 1. So if you wanted to complete the square, you'd have to come through and divide everybody by a 9. So your middle term is going to be 4 over 9. And then when you go to fill out the blank, you'd have to take 4 over 9, cut it in half. So then it'd be 2 over 9, and then you have to square it. I'm gonna veto completing the square on this next question, guys. Let's just go ahead and do quadratic formula. Opposite of b, so k equals. Opposite of b would be negative 4. Plus and minus, b squared would be 16. Minus 4 times 9 times 5. Well, looks like we're going to have another complex solution set. Over 2 times a, which would be 2 times 9. So only partially simplify this, please. Please calculate the discriminant. Oh boy, let's see. Let's try. Yeah, 1, negative 1. I give up. Negative 164, okay. Now, I'm feeling like, yes, obviously the negative's going to have an I, but 164 has to be divisible by at least 4. Is it something bigger than 4, though? What is 164 divided by... Does 16 go into? Shouldn't. Because that'd be 160. Is it just 4? What is it when you divide 164 by 4? Which is, yeah, prime, so we're good. All right, so for negative 164, the way I want you to think of it, pull out the squared term first, put the negative 1 in the middle of it, and then the leftover part at the end. That's a nice way to break down complex radicals like this. So square root of 4 is going to become a 2. So this is a 2, this is an I, and then the square root of 41 is just going to remain. So we have negative 4 plus and minus 2i squared roots of 41. All of it over 18. And I bet you feel like we should be done because that was a lot of work, but we're not done. Look at all your coefficients. You have a negative 4 and a 2 and an 18. All of those are divisible by 2. So come through and cut them all by a 2. So this becomes a negative 2, this becomes a 1, and this becomes a 9. Final solution set, negative 2 plus and minus I square root of 41 all over 9. I lost my k equals part, but that is what k equals. Yuck! But you know what, guys? 20 times better than doing completing the square on that one. And as much as I love completing the square, it's not always the best option. All right, let me kind of look ahead in the questions. Oh, boy. Let's do one more. You know which one I like? They're all so good, though. Let's do 15. All right, so 15. First of all, not quite in that standard form of quadratic, so depending on what method you want to choose, you might want to think about what you want to do to rearrange the terms. For most kids, they just always place it back in standard form, and then they decide after that. So if you brought everything to the left, you'd end up with 6x squared minus 10x plus 10 equals 0. Which is fine, except if you look at those coefficients, do you notice anything? They can all be divided by 2. So let's do that at least. So 3x squared minus 5x plus 5. Now, if you want, if you're on like a massive homework assignment or a summative where you don't want to have to do extra work, you can actually determine what method is best by simply calculating the discriminant. Remember your friend the discriminant? So if you can just quickly figure out b squared minus 4ac, then I'll know whether it's factorable, and I'll also know whether I have some funky stuff coming up. So what is 25 minus 4 times 3 times 5? Something negative? Okay, so since it's something negative, I'm going to be having i's in my solution, so I shouldn't even consider factoring. That's out. So it's up to you guys. Do you want to try completing the square in this one? They're shaking their heads no, because I'm telling them no. Why would I not really want to do completing the square here? Because the first step you'd have to do is divide everything by a 3, which would give us lots of fractions. Not today, friends. All right, so instead, let's go back to quadratic formula. So x equals opposite of b is going to be positive 5. Plus and minus square root of b squared. I'm just going to write down 25 so I don't have extra parentheses to worry about. Minus 4 times 3 times 5. Now y'all just calculated the discriminant for me, so I'm hoping someone remembers what that was. What is 25 minus 4 times 3 times 5? A little louder, I'm sorry. Negative 35, very good. 5 plus and minus square root of negative 35 over 6. I have good news, we're really close to done. 35 doesn't break down, but the negative is going to come out as an I. And then the other thing I notice is you're not going to have any more simplifying, because you have 5 plus and minus I squared roots of 35 all over 6. That's what x equals. Whew, lovely. 16 is kind of unusual, because look what happens when you start to solve 16. Most kids would subtract the 7n over here, and then these 7n's are going to knock out, and you have this. Now, quadratic formula always works, so if you wanted to do quadratic formula on this, you sure could. Your a is 11, but what's your b term? 0, and then c is 4. So you can do quadratic formula. It's actually pretty easy on this question. But what would be a quicker approach if there's just one variable left in the whole equation? This is a good square rooting question. So you could subtract the 4. And then we're going to divide by 11. Now I got a little bit of bad news for us. This is going to be one of those weird rationalizing the denominator questions. So n squared equals negative 4 over 11. So when you square root both sides, and you square root the numerator and denominator separately, you have a bit of a problem. Now the numerator is pretty nice. What does the numerator simplify to? Plus or minus, what's the numerator? 2i. But this square root of 11 in the denominator does not simplify, and we're not allowed to leave radicals in the denominator, says someone in math. So we have to rationalize the denominator by multiplying it by itself, so squaring the square root of negative 11. But you got to do it up here as well. So we have like a mixed number up here in the numerator. 2i and square root of 11 cannot combine in any way that makes sense for us, so we're just going to leave them separated. So the solutions are plus and minus 2i square roots of 11 all over 11. Lovely. Fantastic. All right, so your homework assignment. We haven't got to the graphing yet. I know. We'll look at it tomorrow. Your homework assignment is on worksheet 5. And we're going to just stick to the front of worksheet 5. So 5A. And you have been assigned numbers 2, 3, 5. Oh, you got it. 7, 10, and 13. Very good. Now there's more coming on the back of it, but we'll get to that tomorrow. All right, sign it off.